Hello. Today we're going to be going over the method of undetermined coefficients. The goal of this is, well, after watching this video, you should be able to solve second-order non-homogeneous differential equations using the undetermined coefficients method. Now, this method it's a stepwise procedure. Like, you'll do one thing after another, and what you'll do first is you'll solve the general solution for the homogeneous version of this equation. Then you'll select an appropriate form of the particular solution and determine the particular solution for the two derivatives of that. And you'll plug them back into your original non-homogeneous equation, and you'll solve. And the most difficult part of this method really is finding the particular solution in the method. After that, solving is fairly straightforward. So, what can we solve? So, the general form of solutions you'll be solving with this method is second derivative plus first derivative plus, okay, that's supposed to be not derivative. That's supposed to be just cy equals a function. And this is the general form of the non-homogeneous differential equation which you'll be solving. And your solution, we know from theory that solution will be equal to YC is our complementary solution, or the solution to the homogeneous part of the equation, and YP right here is the particular solution. The complementary solution can be different things depending on the roots, whether they are distinct, repeated, or complex, and that's found by setting the right-hand side of the equation to 0 and solving. But now we must solve for YP. And our G of t, our equation, our right-hand side of the equation is a polynomial. We can solve for the general form of it if it is a polynomial, exponential, or if it's sine or cosine. We can guess the general form of the solution, and we'll know everything except the coefficients, which is where this method gets its name, the undetermined coefficients, because that's what you're solving for here. But the table here shows like what for different G of t you'll get. So for an exponential e to the kt, you just get e to the kt multiplied by some coefficient. For a polynomial, t to the n, you will get a polynomial expansion. So if this was t squared, this would be it would be at squared plus c plus bt plus c, and so on for whatever power you have for this function. And then for sine or cosine, you would get the combination of the two, which is a sine of t plus b cosine of t. Some important notes: you'll want to find the most general form of the equation you found from the results of the last slide. And the other thing is you need to make sure that your particular solution and your complementary one do not overlap, because otherwise, whenever you get your final solution, they will cancel out. The way you avoid this is in your YP, your partial solution. If there is any part of that overlaps with your homogeneous solution, you will multiply all of YP by t. And if there's still overlap, you'd multiply by t again, and so on, till there is no overlap. Okay, and then I have an example here. So for this differential equation, y double prime minus 4y prime minus 12y equals 2t cubed minus t plus 3. First things first, you find y homogeneous, or the complementary solution. So here we just go r squared minus 4r minus 12, and you see we're setting this right side equal to 0. And you just solve for the roots, which are -6 and 2. And since they're distinct, the solution is c e to the -2 plus c to e to the -6t. And now we take our y particular, and here we see it's a cubed polynomial. So our yp is equal to at cubed plus bt squared plus ct plus d. That's an expansion we saw from earlier. Next, you'll want to find the first and second derivative, and you'll plug them back into our original equation here. It looks a little messy, and this is just a lot of algebra really, but then after this, you'll solve for a, b, c, and d. And in particular, y double prime here, you're putting y double prime p, y prime, you put yp prime, and y here, you put yp. After that, you'll be able to solve for all of our coefficients, a, b, c, d in this case. You'll plug those in and you get your yp. And finally, to get our final solution, we know it's equal to y complementary plus y particular. So we just take our yh from before and add that to our yp, and that will be our solution. Thank you for watching.